Nakita niyo yung nakasulat sa screen? You are muted. You are muted. Okay. Okay, can you see what's on the screen?
Yes po.
Okay, what is it?
Good morning, sir.
Okay, good morning class.
Good morning, sir.
Okay, good morning, good morning. Okay, let's get started. Let's continue our discussion. Tayo dito, no? Kumuha tayo ng ayan, sa mga memes na introduction natin sa okay, last meeting we started about the perception of people with regards to philosophy, and then the perception of people with regards to science. Even those perceptions are even those perception creeps to the academe, no? Even high ranking academe or high ranking scientists also fall to those stereotypes of philosophy and science. So is this stereotype don't listen to anyone in the philosophy department. In contrast, we have science. And we talk about empiricism, that is using your senses, rationalism, thinking only. And then we talk about experimental and theoretical science, theoretical physics. It's using mathematics. And then I asked you about 3 questions. Number 1, is philosophy dead? Number 2, the sciences has outshone philosophy, and number 3, are scientific claims 100% true? Okay, take note of that. We're going to go there later. I will also discuss about the 6 major branches of philosophy: metaphysics, epistemology, logic, reason, aesthetics, ethics, and political philosophy. You can say there is no natural philosophy on the current discipline of philosophy. Okay, the reason is that natural philosophy, which used to be a part of philosophy, evolved into something else, evolved into natural science, the science we know today. Okay, and right now natural science is evolving into something else. Right now science is highly mathematical. There are a lot of theories that do not have that were not confirmed through experiments, but are mathematically but were deduced mathematically. Examples of those are the Higgs boson. Right, around 50 to 100 years, the mathematics showed that there are particles called Higgs boson, but then it took 50 to 100 years to discover its existence. So nauna muna yung math came first, and then the discovery of the particle. Wait a minute here. Okay, before this is a collider, Large Hadron Collider. This is a underground network. So in the Large Hadron Collider, particles are being smashed together. Okay. Then they discovered the Higgs boson, or the God particle. Basically, it's the particle that give mass to objects. No? Why do we have mass? So it's the Higgs boson. They confirmed the existence of it. And then the next one is black holes. Black holes. Einstein's theory predicted that black holes could exist. They warp space so much that they create very strong gravity regions. Then after 50 to 100 years later, scientists discovered black holes. Okay. So a lot of scientists are now using advanced mathematics to predict phenomena in nature. So it's not just purely experiment. Another is string theory, but this is very questionable. The mathematics work for string theory. Okay. This one is a prediction that at the beginning of the universe there could be, listen carefully, at the beginning of the universe. Well, that's not science, right? Because this is ontology under metaphysics. At the beginning of the universe there were membranes, right? Like these membranes under, sometimes when they collide they create a big bang. They could be mini big bang, creating multiple universes. But this is very what's that, far-fetched idea, no? It's very far to establish science. It's highly theoretical. Okay, now let's talk about the evolution of science. Science as we know it is not like this around 200 years ago. It's a very different science. Take for example the observation of falling apples, right? If I ask you to explain why apples fall, see now, let's ask some of you why apples fall. I think you can say something about that. Why apples fall? Anyone?
Sir, because of the gravity of the earth.
Okay, that's a good one. 1 point for you. Any other answer? Why apples fall?
Because it's right.
Okay, that's the answer, no? That came from what stage? Here, natural science. The science as we know it. Okay, let's try to answer it using different people from different timeline. One from natural philosophy. Nice. If you're going to ask somebody, if you're going to ask a natural philosopher why apples fall, he will give a different answer to someone who used natural science. Someone who used natural science will give a different answer from one who used theoretical physics. Okay, let's try to answer that question. Why does apple fall? Or how? Actually, how? It's a more appropriate question. 300 BC. So that's around 2000 years ago. 300 before Christ. We have Aristotle. Okay, if you are going to ask Aristotle why does apple fall, he will answer it like this. Wait, so we have Aristotle in 300 BC. Then at 1600s we have Newton, and then at 1900s we have Einstein, and they will give a different answer for each one. Okay, Aristotle, he will say that the apple fall because it is made up of earth and water, and earth and water moves towards the center of the universe. Okay, let me explain that on detail. According to Aristotle, there were 4 elements. There are 4 elements that made up all things on earth. Okay, this is Aristotelian explanation. Aristotle. Okay, according to Aristotle, there are 4 elements that make up anything on earth. For example, the food you eat is a combination of water and earth. I'm going to draw box for earth. Right. It's a combination of water and earth. The cell phone you are holding is composed of earth elements. No. Earth elements. While the air you are breathing the smoke is composed of air elements. So note that out of the four, two of them can be considered heavy elements. So out of the four elements, fire, water, earth, and air, two are heavy. Two can be considered heavy, while two can be considered light elements. Okay, what do you think are the light elements here? Anyone? No recitation? No, I think this is easy one. Okay. Which
Air.
element do you think?
Fire and air.
Air and
Fire.
fire. Yeah, right. Okay, according to Aristotle, we have two light elements, air and fire. Okay, for the heavy ones, we have two left, and that would be water,
What?
and earth. Okay, so that was according to Aristotle. And there's another. According to Aristotle, earth is the center of the universe. So we have here earth. It has a very special place, earth. Then we have here the different planets revolving around earth, and so on and so forth. No, that's the planets. Okay, it's a very special place in the universe. Okay, according to Aristotle, all elements, all heavy elements tend to fall, and then it did not mention fall, will move towards their natural place, will tend to be attracted. No. They tend to move. He said, as if the Aristotle talks as if matter have their own consciousness. He said that earth elements moves towards the center of the universe, according to him. So same with the water. The heavy elements, they will try to move towards the center of the universe. Okay. While the light ones, like fire and air, as you can see, fire now, and smoke tries to go up, while the light elements tries to go up, away from the center of the universe. Okay, that is Aristotelian physics. Now, why does apple fall? Well, apple is a combination. If you draw an apple, okay, apple, what do you think are the two elements present in an apple? Apple is composed of what elements, according to Aristotle? Anyone?
Water and earth, sir.
Yes. Okay. Water and earth. Water and earth. Okay. So it's composed of water and earth. And if the apple is composed of water and earth, what would be its tendency? Go up the atmosphere or go down towards the earth?
Go down, sir.
Okay, go down.
Go down,
Very
sir.
good. Because according to Aristotle, they will go towards the center of the universe. So where are we? Okay, very good. So that was Aristotle's explanation. This apple will try to go to the center of the universe. Okay, now let's go to Newton. Newton has a different explanation. According to Newton, they are not. It's not because they are made of four elements. Actually, according to him, Earth and the apple are pulling each other through a force known as gravitation. Okay, so he has a different explanation. It's not like this. According to him, okay, it's a different one. So to Aristotle, things like apple. If we try to draw a tree, let's try to draw a tree. And we have here the falling apple. Okay, according to Aristotle, this fruit, its natural place is something lower, no, towards the ground, something lower. Newton, the reason why apple fall, because of a force. Okay, there's a force. So he introduced a new concept. There's a force that attracts apple towards the ground. Furthermore, he said that the tree, this tree, is actually attracting the apple using this through this force. Same with the apple, it's also attracting the tree, and the apple is also attracting the ground. That's a very what's that? It's like preposterous what's that claim. That's, if for example you are a Newtonian physicist, you will find this ridiculous, right? Things are attracting each other. This is not the theory of Aristotle. Aristotle has a very different, straightforward theory, very simple theory, easy and straightforward. However, Newton, everything, even the moon, right? Even the moon is being pulled towards the earth, and the earth is being pulled towards the moon. That's according to Newton. Everything attracts each other. Now think about it. Now it's a very different theory of gravitation to Aristotle, but Newton has a very good Newton's theory has a very good prediction, and that is, okay, using his theory, people can predict the tides, right? Tides. Why do you think there is high tide and there's low tide? It's because of the gravity of the moon, right? So Newton predicted that. And for example, the moon is here. Let's draw. This is the Earth. This is the Earth. Right. This is the moon. Okay. Newton's theory is that everything attracts each other, and everything attracts each other. So that means the moon is also attracting the earth or pulling the earth, and that also includes the water on earth. So the water near the moon tend to bulge, right? And there's a little bulge also here. There's also a little bulge here. No, it was not, the moon is not attracting it. So water towards the moon is being attracted by the moon. As the moon revolves around the earth, as the moon revolves around the earth, so is the tide. The tide is changing. If you look at the calendar, let's try to look at the calendar. If you try to look at a calendar, sometimes you can see this one. There are moons in it. This is no moon, or ellipse moon, and then we have half moon, then we have full moon, and then we have the other half moon here. Sometimes you can see this in a calendar, the half moon, the full moon, and the other half moon, and then the eclipse moon. Okay, the reason for that is those calendars are used by the fishermen. Alright, those calendars are used by the fishermen to predict what would be the tide during the evening. So there are fishermen who go to the sea to fish during the evening, and then they try to look at the calendar to see what would be the tide. Okay, so this is Newtonian gravitation. Around 300 years later, we have Einstein. Einstein have a different idea about gravity. According to Einstein, Earth has deformed space around it. Okay, so for Newton, for Newtonian gravitation, it is the objects that attract each other here. We have objects attracting each other. But when it comes to Einstein, it's not the case. Okay, according to Einstein, Einstein above. Okay, what? Let's just look at a picture na lang. Instead of drawing, I'm going to show you a picture of Einstein's theory. Okay. Here. Okay. According to Einstein, matter folds space. This is his prediction. And then, if there is another matter, I don't think that's an accurate one. Okay, like this one. Alright? According to Einstein, matter folds space like this. And then, if there is another matter caught into that folding, then it will be attracted towards the other matter. So, according to Einstein's theory of relativity, there are two Einstein's theory of relativity has two implications. That is, if you remove space, this one, the fold, there is no gravitation. Okay, that's Einstein's theory. If you remove this sheet of paper, there is no gravitation. These two will not attract. But based on Newton, alright, not according to Newton, but based on Newtonian theory, right, even if you remove this space, these two will attract. That's Newtonian. But for Einstein, this space is required, this folded space. Okay, why do we believe Einstein instead of Newton? Because Einstein predicted another phenomenon relating to gravity, and that is, what if this space is so folded down? What if this object is way too heavy? So this is one of Einstein's prediction. Okay, so if if the object is too heavy, it will create this one. This folding, that one. It's so stretched downwards that it will create a very strong gravitational field around here. So Einstein's math predicted this one, that this is possible. And then later physicists discovered black holes like the ones in the center of our galaxy. Of the Milky Way. So we have one. Aside from the ones floating around, we actually have one at the center. That one. Here. We have one here at the center. Aside from the ones floating around the Milky Way. So, as long as you have a very as long as you have a high density or condensed matter, you can form a black hole. Okay, so that's how the different so you can see that science actually evolves, no, from Aristotle to Newton, of things attracting each other, and then to Einstein. Now it is wrong to explain, if you listen to your physics class, it is wrong to explain that Earth itself is directly attracting the apple. No, it's because the explanation for gravity is because space is bent around it, and it makes very good predictions. This theory makes very good predictions. Another prediction is that, I think I illustrated the other one. Another prediction of Einstein is that another one is that if space is bent next to a planet, then a light traveling near that star is going to be bent. Its direction is going to be bent, like this one. Okay, and this has been confirmed. So
Sabi mo na nalaglag yung apple kasi hinog na.
Pakimute.
Natural theory. Natural science theory. Nakaon ka, gagi.
Okay. So we have evolution, no? Different explanation for gravity. And the most accurate one is no longer Newtonian physics, but our books today still talks about Newtonian physics, right? The most accurate explanation is Einstein's theory of gravitation. Okay, but we still use Newtonian physics on Newtonian calculations based on Newtonian physics, because Newtonian physics is easier to calculate compared to Einstein's physics. Okay, so Aristotle has a simple explanation, Newton has a little complicated explanation, and Einstein have a very complicated explanation. Right? When it comes to uses, we still use Newtonian physics because it is very good at approximating, right? Approximating how objects behave. For example, in engineering, we actually use Newtonian physics. However, for everything else, including space, satellites, space exploration, we use Einstein's theory. Okay, so Newton is very good at approximating. Okay, let's continue. Okay, now this raised to two questions. Number one, what are the foundations of science? Okay, and number two, why do we change theories? If science is so good, why do we change them? And what are the criteria on changing theories? Right, we know this one. There are a lot of changes in science, but why do we change them? Before we talk about change, let's talk about the foundation of science. What is it based upon? Right? What are the grounds to conduct science? Okay. Actually, none. There is no ground to conduct science. What we do is make assumptions. Okay. So what are assumptions? What are these things? Okay, I'm going to ask you a question. Okay, I'm going to ask somebody, why does your CP monitor work? If you're using a cell phone or PC, why does your CP monitor work? Anyone? Why does it work?
By chemical energy.
By chemical energy. Oh, that's a good one. Chemical energy. Okay, that could work. Oh.
May points ba yun, sir?
Chemical energy. I don't think that's kumbaga accurate. I'm going to give that a point, pero half a point. Oh, chemical energy is one explanation why the monitor works. Okay, let's use that one. Although there are two, chemical energy and electrical energy. Okay, sige, let's use the more accurate one. No points, wala yung points. Okay, let's use the more accurate one, no? Electrical energy. Let's ask another one. Why does it work? So I'm going to continue asking why, ha? Why?
Sir, because of light.
Because of light? What else? Why does electrical energy work? Why does your fan work? Why does your
Because of
bulb?
energy.
Okay, because it's energy, no? Because of energy. And then I'm going to ask you why. Why does energy work? So again, so I can ask you infinitely. So I hope you see the pattern. No? I can keep asking you why, electricity why, energy why, and then if you give an answer, I can ask you why, and so on and so forth ad infinitum. So infinity, ask of why, until you run out of answer, right? Okay. So all of us wish that we can answer every why on the universe. No? Why? There's an answer to it. However, we expect that there will be a foundation here. There would be a dead end. Kumbaga, there is a dead end here. Why? However, the closer we go to the dead end, the more debatable the answers are. So if you take philosophy, the more fuzzy, the more debatable, the more questionable the answers are, as you keep asking the why question. So what scientists did is that instead of figuring out why, right, they make assumptions. Okay. So they stop somewhere here, and they stop somewhere around here. And then I don't think this one. Right, so there's a why. They stop somewhere here, like that. They stop somewhere here, right? And then they agreed to, okay, let's assume this is true. We're not going to ask it. We're not going to ask this question. Let's just assume it is true. That means they have a truth. They're not going to debate around it. Whatever those statements are, I'm going to reveal those statements. Okay. We're not going to debate about it. Let's just assume, let's just pretend that this is 100% true. Let's pretend that this is 100% true, and then let's build up from it. So they pretend that this is true, and then they try to build science out from it. But note, there are still unanswered question. Again, this is somewhere in the middle. No? You can still ask, and then science will not be able to answer it, because the foundation is somewhere at the middle, and there are questions behind it. There can be another thing, like say another term here, and then it will ask, so on and so forth. So that's the nature of science, that there is, it's actually floating somewhere, floating in nowhere. Okay, now the question is, ano ba to? What do scientists agree on? What claims do they agree without proof? They haven't proven it, but they already agree. So it's like faith, no? Like there is a foundation that is not based on something deeper. Some claims that are deeper. Okay, but it's not equivalent to faith, because they realize, they admit that it is just an assumption. When we say assumption, they pretend it to be true, and they recognize that they are pretending. That's an assumption, which is different from faith, because it's you claim that it is really the case. It's really the case. Like sometimes it is the ultimate case, ultimate foundation. Science is you pretend it is true, and you recognize that you are pretending that it is true. Okay, what are these things? It's better to show what are the assumptions of science. So if you're a scientist, you must believe this, but recognize that it has no basis. You must believe on this. Number one, there is an objective reality shared by all rational observers. So this is one. Most scientists do not say it, but it's like faith, no? Similar to faith, but not faith. No? There is an objective reality that are shared by rational observer. Why is this a questionable belief in science? Right? Why is that questionable? Okay, the reason for that is we don't know if we are inside a matrix. If I'm going to show you matrix. Hopefully you have watched Matrix. I'm going to show you Matrix. Okay, have you seen this movie? This one, Matrix? Yes or no? Have you seen the movie Matrix?
Yes, sir.
Okay, very good. Sige.
Yes, sir. Yes,
Who was
sir.
that? Who was that? Let me see. I cannot see your
Keanu
name.
Reeves.
By the way. Who said yes? Who said yes? Sino nagsabi ng yes? I cannot see you. Hindi ko makita yung pangalan mo. So, less than 1 minute na pala. Oh. I'm going to give another link to our Google Classroom. We Okay, let's continue. Okay, assumptions of science. So we pretend this to be true, and then we base our actions on it. Alright. Okay. Before we go to our next assumption, I'm going to show you a video relating to the first one, the first assumption. There's an objective reality. Living inside a matrix that the world he thought was real wasn't real. So let's draw it again. So if we have Neo, so let's draw Neo. So Neo, alright. Oh, most of us think that this is the case. Most of us are empiricists actually. Most of us think that no. If we see an apple or what is it, a cup? If you see a cup, okay, if you see a cup, most of us think that there is an actual cup out there, right? Most of us think that we are seeing an actual cup out there, and then we interpret the light rays entering on our eyes as the ones bouncing from a real cup outside. Okay, so we think that there is a real cup outside. But what happened in the matrix is that the brain, let's have another color for Neo. Alright. Neo is plugged in a computer. Right? Neo is plugged in a computer, and then the computer is tricking his brain. It's tricking his brain to see things that there is, to see things that are not real. Right? It is tricking his brain that there is an apple, a chair, or a television set. No, even though there is no such things outside. Okay. This could be applied to us. No, we don't know if we are tricked by a supercomputer to think that there is actually a pen on front of you. We don't know if we are plugged to a computer like Neo. So instead of answering that question, scientists assume that we are on base reality. Scientists assume that we are in a real world. No, scientists assume that we are not like Neo. Okay, so that's what it means to assume something. No, okay, that's the first assumption in science. There is an objective reality out there. The second is that this
Sir, wala kami makikita.
Ha?
Wala kami nakikita, sir.
Oh my god. Okay, sayang.
Picture niyo lang
Akala ko
po.
sir, nagsasalita ka lang talaga sir. Wala.
Okay.
Ito yung video po sir kanina, wala din po kaming nakita.
Picture niyo lang po sa screen niyo po.
Akala ko talagang
Sandali. Yun nga na kasi nalilito ako nito sa Zoom eh.
Akala ko nagloko na naman yung cellphone ko.
Okay, sandali lang ha. Ano ba
Hindi
yun?
porket bago.
Yeah.
Jay, salamat sa api Jay, bilang kita bago.
Okay, ito ba yan? Screen. Ayun, hindi nyo nakita yung video. Okay, ulitin natin lang. Ito. Yung first assumption. There is an objective reality out there. Ayan. Na yung kutsara or plato or ano ba yung nasa harap mo, yung cellphone mo na yan, meron talagang ganyan na cellphone. So as you can see, Neo find it hard to accept that he was tricked by a supercomputer. Bataya. So this is what happened to Neo, no? He was plugged into a supercomputer, and then the supercomputer is feeding his brain things about things that does not exist. So that was what happened to Neo, no? So by feeding Neo electrical impulses, Neo thinks that there are chairs, sofa, that there are chairs, there is a television, there is Morpheus, and so on, right? So we don't know which is true, whether there is actually an outside objects like the cup in front of you, or the CP you are holding right now, or the PC you are facing right now. We don't know if those are actual real things or we are plugged to a supercomputer. Okay, we cannot tell which is which. So what scientists do is they assume that this is true. Okay, instead of debating about that like most philosophers do, instead of debating like that, most scientists assume that there is an actual real world out there, like this cup. So that is the first assumption, that there is an objective reality shared by all rational observers. When we say objective, you can see the cup, another person can also see the cup, then another person can see the cup. So it's objective. Okay. Then second, this objective reality is governed by natural laws. So this is what scientists believe. Instead of debating whether there is natural laws or not, they assume that there are natural laws, and there's no proof for that. There's no proof for this statement, because if you say, well, science proved that there are natural laws, but then again, science is based on the assumption that there are natural laws. So it's circular, parang Ouroboros, no? Circular reasoning. Circular reasoning, sabi doon. There are natural laws. How do we know that there are natural laws? Well, through science. But how does science work? Well, we assume that there are natural laws. So nagsa-cycle lang din siya, no? Nag-ano lang siya, kumbaga Ouroboros, sa cycle lang. So it's kumbaga circular. So we just assume first that there are natural laws para meron tayong start, and then we do science, and then we try to discover about the objective reality, and it was confirmed na meron tayong natural laws. But then again, realize that the basis of science assume that these things exist. Sa pinakauna niyang cycle, assume that the natural laws exist. Third, ano ba yung assumptions ng science? Okay, nature has uniformity of all laws, and most, if not all things in nature must have at least a natural cause. So actually dalawa to na pinagsama na assumption. Number one is uniformity. Uniformity. Kung may gravity dito sa Earth, may gravity din dun sa Mars. Kung may gravity sa Mars, may gravity din dun sa Pluto. Okay, may gravity sa Pluto, may gravity din dun sa next na Earth-like planet. If may gravity sa next Earth-like planets, may gravity sa next galaxy. Ganon. Kung may gravity sa isang galaxy, may gravity din to the other galaxy. So yan yung sinasabing uniformity of laws. And second, merong natural cause lahat ng bagay. So that's the reason why scientists experiment. Kasi they assume that everything has a natural cause. Hindi most, if not all, no? Most of the things has a natural cause. When we say natural cause, you can discover it through experiments. Okay, so yun yung assumption ng science. Okay, so we have three. Merong objective reality, and they follow natural laws, and the natural laws are uniform across the universe, and there are also natural causes. Okay, number four. Okay, Number 4, notice na yung border niya, nilagay ko dito, green na border. Tapos pagdating dito sa number 4, blue yung border. Because number 4 talks about the experimenters, talks about the scientists. Ito, number 4. Experimenters won't be significantly biased by their assumptions. Ano bang ibig sabihin ng number 4? I'm going to draw something on the screen and you try to guess what it is.
Sir, snowflake.
Snowflake. Is it snowflake now? Still snowflake.
Kala ko lizard, sir.
Lizard, could be a lizard. What could this be? Sandali
Sir,
lang.
parang synapse.
Synapse.
Palaka, sir.
Palaka. Okay. If you said
Nasa pocket pen,
you
sir.
said Pokemon. Oh, it could be ano, moss, no? Yung moss, yung green moss. Oh, pwede plankton, pwede coral, pwede siya kahit ano-ano, no?
Germs.
Germs, pwede alien, oh, kahit ano-ano. So yan yung tinatawag natin na bias. Oh, bias. Bias natin. And where do we get this bias? Saan galing tong bias na to? Okay, because we have stored knowledge, no? Meron tayong stored knowledge. If you are a medical professional, if you are from medicine, if you are a professional doctor or professional surgeon, he will say, most likely you will say that this is a neuron or neuron cell. Neuron cell. But to people who do not know what a neuron cell is, for those people, they cannot say that it is a neuron cell. Okay? So the doctor base his observation on a theory. Meron siyang nalalaman, kumbaga. And then he make yung conclusion niya sa na-observe niya is based sa kanyang nalalaman. We call that theory ladiness. Theory ladiness. So yung theory na alam niya naka-affect sa observation niya. So yun yung theory ladiness. Sabi dito sa assumption number 4 that okay, people can be theory laden pero hindi masyado. Yan yung assumption sa number 4. Instead of debating that one, ito na lang in-assume nyo na. Experimenters won't be significantly biased by their assumptions. Anong nalalaman nila, anong mga belief nila. So yun. Hindi masyado biased. So instead of debating that one, assume na lang na true. Number 5 is still about experimenters. Experimental procedures can be done satisfactorily without any deliberate or unintentional mistakes that will influence the results. So this talks about the competence of the scientist, no? That you can satisfactorily deliberate, but basically you can conduct an experiment correctly. Ganon yung ibig sabihin ng number 5, no? Pwede that a person or a scientist can conduct an experiment correctly, no? Walang mga mistakes, intentional man or deliberate. So instead of debating that one, whether scientists can conduct an experiment or not, let's assume scientists can conduct this experiment. So yan yung assumption ng science, no? Without proof yan, hindi pa yan dinebate. If you're a philosopher, you can attack any of these assumptions, no, ng science. So yan yung pinaka groundwork ng science. Ano pa? Okay, ito pa. When pag-highlight ko ng red na border, that means it's a methodology process. Ito sabi sa number 6. Reality can be discovered by means of systematic observation and experimentation. So in other words, yung assumption ng science, isa sa assumption ng science is empiricism. Kumbaga, we learn through our senses. We learn through our observation, no? So inassume ng science yung empiricism, but empiricism is not the only possible way of claiming how we know things, no? We mentioned that there are dalawa yan magkalaban na school. Number one is empiricism, and number two is called rationalism. So sa empiricism, school of empiricism, we know things through touching them. Yung example ko last meeting about Coke, no? You will know the taste of Coke by tasting it. You cannot know it otherwise. So empiricism makes use of our senses. Okay, rationalism, sabi naman ng rationalism, hindi mo alam kung yan ba talaga yung lasa ng Coke. Posible na doon ka sa matrix, tapos tinitrick ka ng computer na yan yung lasa ng Coke. Rationalism, hindi tayo sure. Let's not ano ba yan? Let's not rely on our senses, no? Let's rely on our rational thinking, no? Let's rely on our thinking. Thinking naman tayo. So ito ulo yung ginagamit, loob ng ulo, no? Yung loob ng ulo yung ginagamit. Ito naman yung 5 senses natin. Yung mga senses natin. 5 common senses natin. Okay? So ulo yung ginagamit. Halimbawa, sinasabi ng mga rationalist na you cannot be sure of anything. You cannot be sure na yan talaga yung lasa ng Coke. Possibly computer yan. But we can sure about one thing, and that is our minds exist. Yun lang yung sure tayo, our minds exist. Sabi ng mga rationalist. Sabi nga ni Descartes, I think, therefore I am. Dahil nag-iisip ako, it means na I exist. Yan yung rationalism. Kakaiba yung ano niya, yung mga claims niya. And then empiricism, almost all people are empiricists. From baby, lahat niya nagkakapakapa yan using the 5 senses. But there could be people who are rationalists, no? They are going to doubt their senses. Okay, so instead of debating, hindi pa to resolved, no, kung makapagtitiwalaan ba talaga yung senses natin, or nandun ba tayo sa matrix, o ganyan. Pwede lang tayong tinitrick so hindi pa to resolve. So instead of resolving that one, inassume na lang ng mga scientists na ito yung totoo, na we can use our senses. So empiricism na yung pinili ng mga scientists. Ayan, that's why sa science, when we say science, it involves observation. Nag-observe ka. Yung mga pumupunta ng bukid, mag-observe ng mga iba-ibang klase ng halaman, no? Tapos yung sandali. There are people who go to the forest to observe different kinds of plants, and observe different animals, observe their behavior, and sometimes they experiment. Anyone, so this is good for 2 points. What is the difference between observation and experimentation? Anyone? What's the difference between the two? Bakit separate sila? May observation, why are they separated? Okay, what's the difference?
Observations are we use our mind, while experiment through experience.
Okay, that's a good point, but I'm waiting for a bullseye answer. Daplis, no? Actually, daplisan mo siya. Any other answer? How is observation different from experimentation? These are the 2 methods scientists use.
Sir, pag observation, you will not do anything, you will just write your analysis, and then you just watch whatever is there. So if you have experimentation, meron ka ng method and mga ways kung paano mo siya gagawin. Ganon?
Okay, that's a perfect answer. Bullseye. Double hit pa. Okay, that's perfect na yung answer na yun. Okay, that's 2 points. Paka-record, that recitation is 2 points. Worth 2 points. So, observation on natural lang. Wala kang, sandali, nagtatagalog na naman ako. When you say observation, you're not going to do anything about what you are observing. For example, if you are observing swans, you're observing corals, you're not going to touch it. You're not going to do anything on your subjects, no? When we say experimentation, you have an artificial setup, no? You have a methodology, as your classmates have said, no? You have a setup for that. So we can say that observation is natural while experimentation is artificial. There is a setup. Okay, well done. Okay, and then we have number 7. Random sampling is a representative of the entire population. So number 7 is that ito yung ibig sabihin niya. Okay. Halimbawa, yung tubig na lang. Somebody mentioned about snowflakes kanina, no? So, ito. Snowflakes. Okay, what is the freezing point of water? Ano yung freezing point of water? In degrees Celsius. That's snowflake. Ano yung freezing point ng water? Nagiging
0
ice.
degrees
0 degrees. Anong unit?
Celsius.
Okay, very good. Pakilagay niyan 1 point, no? At 0 degrees Celsius, water freezes. Nagiging ice siya. Near 0 degrees, nagbubuo siya ng mga snowflake. Near 0 degrees. Sabihin na lang natin 4 degrees Celsius. Oops. Sabihin na natin 4 degrees Celsius, bumubuo siya ng snowflake. And we observe it across the world. Sa buong mundo, we observe it that around 4 degrees Celsius bumubuo na yung snowflake. So lahat 4 degrees Celsius. Sa Korea, na flag ng Korea, Pepsi, di ba? Pepsi. So may ganun. South Korea, yan. Okay, na-observe mo ito yung nangyari. 4 degrees Celsius naging ice yung naging snowflake yung tubig. Tapos pagdating mo ng Russia, Filipino naman ako. When you go to Russia, you also observe that at 4 degrees Celsius, water turns into a snowflake. And then, when you go to USA, you still observe the same. Water turn into snowflake. And then, when you go to Antarctica snow flag. When you go to Antarctica, you observe the same. Water turns into a snowflake at 4 degrees Celsius. Lahat sila. All of them turn into snowflake at 4 degrees Celsius. Let's say we observe another planet far away. There's another planet. Let's draw the star, and then we have a planet. Okay, and then scientists calculated the distance of that planet to the star. So calculated nila. Okay, then they calculated the heat, how much heat, and how much heat. And then in their calculations, a large portion of the planet is experiencing a 4 degrees Celsius temperature. Okay, a large portion of the planet is experiencing a 4 degree Celsius temperature. Now, if there is water in it, pag merong tubig dyan, if there is water on it, may tubig, what do you think is the form of it? Anong yung form ng tubig? We mentioned that during 4 degrees Celsius, it's snow. Or if it lands on the ground, it turns into ice, diba? Okay, what do you think is the form of water here? Is it A, gas, B, liquid, or C, solid? Okay, what is the ayun, I underlined the answer, no? Okay. Scientists will conclude that since we observe on Earth that at 4 degrees Celsius water will turn into solid, on that planet experiencing a 4 degree Celsius temperature, the liquid will be on its solid form. So yung tubig nasa solid form siya. Okay. Not only that planet, if there is also an asteroid here, okay, and then it is also experiencing a 4 degree Celsius temperature, then scientists will expect that the water is in solid form, also solid. If you have another planet here, a big one, big planet, right? This should be big planet like that, and let's say a part of it is experiencing 4 degrees Celsius somewhere here, a part of it near the uh, near the sun, the part of the planet facing the sun. Okay, so scientists will expect that the water on that planet will be also in solid form. Okay, scientists will expect everything at 4 degree to be in solid form, although scientists haven't gone to that planet. Hindi nakapunta ka ba ng planet na yan? Have you been on that planet? No, but scientists will say that the water there is 4 degrees Celsius because that is the 7th assumption. Random sampling is a representative of the entire population. What you observe in a sample represents what you observe anywhere else. This is very similar to number 3. There's a uniformity of laws. However, this one talks about a method. So number 1 talks about what. Number 1 focus on the objective reality, that there is a reality out there. And the second, who, talks about the experimenters, talks about the competence of the experimenters, that you're not going to be biased, and then you can do the experiments satisfactorily. Okay, who. And then the third is how, talks about the methodology. So actually, we don't observe every water on the entire planet, especially on 7, to conclude that every water will turn into solid. But you must realize that science has assumptions. No, meron siyang mga science is based on claims that are not proven to be 100% true. Kumbaga, these are the claims. Okay, so that's a very humbling knowledge. That science is not that what's that called? It's not perfect, no? That's 100% science is completely objective, observe, and so on and so forth. Now, there is nothing that can debate science. Well, there is, no? There is a lot that can debate science, and that is they start to question one of these 7 assumptions. If you're a philosopher and you don't believe in science, then just state which of these 7 you don't believe in. For example, if you don't believe in objective reality and you don't believe in science, just question any one of these 7 assumptions. But if you're a scientist, you must pretend that all of these, you must at least pretend that all of these are true. You must pretend that there's an objective reality, that there's a natural law out there, that they are uniform all across the universe, that scientists are not biased, that they can perform their experiments well, that we can observe the objective reality, and then we can get a sample and make conclusion about the whole. So these are the assumptions of science. Okay, questions? Do you have any question about this? Meron kayong tanong? Do you have question? Any question?
Nan.
None. Okay, thank you. Okay, so I think we're going to continue this one next meeting. We discuss about science being changeable, right? Here we discuss about, before we talk about the assumptions. Here in evolution of science, right? In evolution of science, right? So science has evolved, and notice it was changed. Okay, it was changed here, different explanation. So the next question, next meeting will be, I think we are going to talk about it a little bit. No? How come that scientific knowledge can be changed? How come that this is possible? No? From Aristotle to Newton to Einstein. How come that we are doing that in science? And then if we are doing that, what is our basis in doing it? What is our basis in changing things? And third question, if we are changing things, if we are changing claims in science, Then did we make progress at all? Right. Did we do uh, did we replace the old one, the old explanation with something better? Is Newtonian physics better than Aristotelian physics? Is Einstein's theory of gravitation better than Newton's theory? He did not explain actually gravity. No? Is Einstein's theory of gravitation better than Newtonian gravitation? So we're going to answer that question next meeting. So we're going to talk about that. I think we have less than 1 minute na lang, no? So next meeting we're going to talk about different theories. Some of them were replaced. So probably in your chemistry you have seen this one. No, ganito yung, this is the atomic model in your chemistry class, but this is no longer true. Right? This is no longer correct. This is no longer accurate. You may be surprised, di ba? In chemistry, you see this one a lot. But now, the accepted theory is like this. The electron cloud model. What? Oh, how come we are changing scientific knowledge? Okay, sige. I think we're going to discuss that next meeting. Okay? We have only 1 minute. That's why I don't use Zoom. No? Because of this thing. This limitation. Okay, so next meeting we're going to talk about how come we change